And greetings. Welcome to the Evidence Reasons Academy. This is the academic channel that's the sister channel of the Evidence and Reasons for the Christian Faith video channel. One reason I'm having two channels is because this academic channel really goes into some pretty brutal stuff as far as technical science. It is not for the faint of heart. It's for those who just want to be bored to tears and to go and comb through technical material. The strength of the case for creationism is um, uh, is strengthened not by short debates, but actually going through and really wrestling with science at the actual professional level, and that's what we seek to do here. So, the topic today is the planetary magnetic dynamo theories, and just briefly, an evidence, I think actually a potentially really good evidence that the Earth is young, is that the magnetic field is decaying and could not have been here for very long. There is a book, Solar System Evolution. Do I have it handy? I don't have it with me, I think. I had it with me earlier. In Solar System Evolution, I was an old Earth creationist who believed that the solar system just kind of assembled through an evolutionary process, gravitation, and after the Big Bang, it assembled naturally. And after I read that book, Solar System Evolution, I just like, no, this looks like it had to be specially created. Comparable to the problem of abiogenesis, it seems more reasonable that the solar system was created. So now the question is, how old is the solar system? If it's specially created, like as in ex nihilo or almost from nothing, and it just appeared, then you could say, well, it maybe happened recently. So there are problems with distant starlight, and people who visit this channel know what that problem is. Problem with radiometric dating, and we're just gonna tackle this one at a time. We burning down kind of the problems with radiometric dating, the Big Bang, and problems with the constancy of the speed of light. That doesn't necessarily build your case. So let's try to build a little bit, find evidences that the world is young. So Godzilla Freak, I can't believe it's great seeing you. It's nice to have at least one person that might want to suffer through this. So he says, I was scrolling through Modern Day Debate, MDD, the other day and realized that you had a debate with JF Gary up B. It was an interesting one for sure. Yeah, I've been telling James I'd like to go one-on-one with someone. And he said, no, 2x2. And that would have been great, me and JF. I did talk, just as an FYI, for those who saw that debate, T-jumping, JF Garapi were on the opposing side. I forgot the handle of the other guy who's a philosopher. And JF surprised me. He's actually a very, very conservative atheist. He was, and T-Jump is pro-choice, which he's favor of abortion. JF Garapi, who's an atheist, is pro-life. And when he said, we destroyed the demon of Roe versus Wade, T-Jump was laughing. I said, what was that about? Was he being sarcastic? And he said, no, JF Garapi is very pro-life. And this could be an interesting debate if he and I went after it, because even though he's an atheist, has similar values to what I have. So gratitude, Godzilla Freak, for watching that. My next debate after that was I didn't win it. It was very difficult. Would have been better for one-on-one, and it's not my specialty, but I accomplished the goal of finding out what the other side has to say, and it's given me a chance to, it's not like we're going to win every inning. This is going to be a long, drawn-out fight. And let me give greetings to everyone else here. Gangster Ghost, thanks for dropping in. And Mark O'Connell says, I can start, but we'll need to watch later as I have to prepare for a birthday party. Oh, hey, that's cool. For those of you who joined here from my main channel, some of them through recording, uh, tonight I'll be premiering just a 6-minute video of where I sing for the ladies. And I did in the video description there just say, hey, come here if you'd prefer to just have Sal just do nerd sessions rather than hear me sing. So so today we'll be exploring the decaying magnetic field. And briefly, if the magnetic field is decaying, and you can go to Wikipedia and it says it's going to decay in 1600 years. Some scientists think in 1600 years we'll have no more magnetic field. Your magnetic compasses won't really work so well anymore. But the more disconcerting thing is that the magnetic field steers the solar wind in a way that it prevents the atmosphere from being stripped off the Earth. So gravity holds the atmosphere on the Earth, but if the solar wind had free reign to just bump into the molecules of the atmosphere, it can hit it so hard that the molecules, one by one, can be just hit at escape velocity. They'll escape the Earth's gravitational pull and never come back. So no magnetic field, no more life at some point. The first thing that will probably get ripped off is the ozone layer, and that could cause climate disaster, and UV radiation, and human life at least will be very, very challenged, and eventually possibly die with the ozone layer gone. And if it's not the ozone layer, it's going to be the entire atmosphere at some point. I don't know how long that process will take. So if the the magnetic field on the Earth is going to decay in 1600 years, whether you have a linear or exponential decay curve, linear curve is just kind of straight, exponential decay curve is kind of like shaped like that. Well, the math guys know what I mean. Whichever way you frame it, if the Earth, if the decay of the field were exponential or linear, at the rate it's going at about 6.3% instantaneously per century, and you could extrapolate that instantaneous slope. You could curve fit it to be exponential decay or linear. The magnetic field would be just absurdly strong millions of years ago, and that would mean the release of magnetic energy in that decay would melt the Earth. And so, that began, some of the Earth creationists said, well, then that may mean the Earth is young, or at the very least, the magnetic field is young, but by way of extension, we would just kind of say, well, that would tend to suggest the Earth is young, because that whatever made the Earth would be tied to how the magnetic field is made. And a lot of people don't know, we really don't understand how the magnetic field exists. We have things like permanent magnets, and we sort of understand that, but then we have electromagnets. So what is it that's creating the Earth's magnetic field? This can then be extrapolated to the other planets. We may be seeing a decay in magnetic fields in the planets too. This may tell us then the architecture, the mechanism of the magnetic field, and it would also prove that the magnetic field had to be created. And it's a reasonable extrapolation, not I would say rigorous, to say then if the magnetic field is young, the planets are young. Granted, that's a little bit, it's not a formal proof, but it'd be pretty strong, because why would magnetic fields spontaneously start to emerge on all the planets about the same time when they only last a short amount of time? Another aspect of this is all the rings in the solar system, the various planetary rings, should only last a few million years, but for some strange reason, they all appeared at the same time, and no one can explain it. Uh, and I need to point that out. So you could either, it's like that's not absolute proof that you have young rings all over the solar system, but and they shouldn't be there. They're very improbable to have had all the young rings at the same time. This would be, it's like a nice way to solve this is the solar system's young, and this would accord with youth of humanity because we're decaying genetically, and a nice way to solve that problem is to suppose humanity miraculously appeared recently. And so all the evolutionary arguments we put forward that life had to be created miraculously, and I'd even say not just the first cellular life, but whole organisms like human beings had to be created miraculously, pretty much in whole form. Then it stands to reason, well, maybe it was all miraculously created recently because of all these decaying properties. The big problems still are radiometric dating, but if we're able to overcome that, and I'm working on that, the young Earth creation model starts to become more and more viable. So that's a 15-minute introduction to where we're going, and now we're going to get into the agony. So now you understand why we're studying the magnetic field. I said this is part 1, and that's because I looked at this paper and it is gargantuan. I don't know if this is going to take 10, 20 parts to get through this. This is heavy on electromagnetic theory, which is notoriously one of the hardest topics in physics for physics students. And I'm going to have to struggle through this, guys, with you. And this is why it's on an academic channel. But if you even get through a few of these sessions, good on you, because this is rough. So Godzilla Freecast, this is the paper or book or something. So if you go to the video description, I dropped a link to where you can get this paper. And one reason I'm doing this live is it benefits me, and through the reading of it, as I go through it, I could share it with you live. So this is really kind of a nice homework study session for all of us collectively. And it also, I'd like to communicate to the creationist community. As we go through this, you're going to see just how hard this fight is. I keep telling people, don't trivialize it. Don't go to Dinosaur Adventureland and hear Kent Hovind. Well, definitely don't go there because it's not safe for you. You'll have to sign a waiver that you're taking a risk there. The place is uninsured and all sorts of problems. And we don't need to go into all the other kind of really filthy, nasty things going on there as far as children being at risk going there. But the problem with Kent Hovind and company is they try to trivialize this and give you really just shallow arguments that many times they're wrong, and I give shows on this, and they just will not hold up scrutiny. To argue this really well, you have to. This is going to be a battle. This is war, guys. This is war, intellectual war. It's not going to be one with little, these little pea shooter type arguments. You need heavy artillery to prosecute this. So there's a question. This is from Humphreys. Definitely not going to be easy. So I put in the video description Russell Humphreys, Ph.D. in physics. His specialty was heavy electromagnetism. Heavy meaning high power. He was working for General Electric. They dealt with high power systems. That'd be, I guess, transformers, big gigantic generators, etc. And so electromagnetic theory, this is right in his specialty. I've disagreed with him on his stuff with relativity. He's a great guy. He has other, this is right in line with his specialty of physics, high powered electromagnetism. So let me now share the screen and let's suffer through this together. And it says in the Bible, for this momentary light affliction is building for us an eternal weight of glory far beyond all comparison. And so, okay, that's just kind of a way to introduce some tough medicine here, guys. All righty. I was at this conference, and unfortunately, the room was packed out that I could not. It was so packed out when he was speaking. I just went to another they had a breakout session in multiple rooms. I just went to one where there weren't so many people because there was standing room only, and even then it was packed out. Everyone wanted to hear Russ Humphreys on this topic. So I was there, but I didn't get my seat reserved. I really wish I had seen it now in retrospect. But so the proceedings of the International Conference on Creationism, Planetary magnetic dynamo theories, a century of failure. And Russell Humphreys of the Creation Research Society. As some of you know, I spoke at the Creation Research Society this past July 23rd. There'll be another, just as a FYI, there's going to be another creationist conference, International Creation Conference at Cedarville University, 2023. So you may or may not see me there, just as an FYI. Okay. Cedarville University is an accredited secular Christian university, but will be recognized by the secular world. It's one of the few young earth creationist universities that has, a very good science department. So let's just read it. Abstract. For nearly a century, geoscientists who believe the Earth is billions of years old have been striving to develop a successful dynamo theory to explain how the Earth's magnetic field might maintain itself over that long time. After reviewing analytic theories, computer simulations, and laboratory experiments, I have concluded that all those efforts have fallen short of proving the geomagnetic field could be maintained by a dynamo. To contrast with this apparent failure, I touch upon the remarkable success of creationist theories in explaining magnetic fields in our solar system, especially the planet Mercury. This contrast supports the young biblical age of the world, about 6,000 years. Praise God. Can the Earth's magnetic field maintain itself? The terrestrial globe is, let me see if I can get this a little bigger on my screen. It's hurting my eyes. Let me see. Just a little too big. Okay. The terrestrial globe magnetic field is a lodestone, wrote Queen Elizabeth's personal physician over 4 centuries ago. He was right about the magnetic field, but wrong about its cause. What he called lodestone is magnetite, an iron oxide mineral that is permanently magnetized by the oriented spinning changes of electrons in its iron atoms. But below a few dozen kilometers, the Earth is too hot for any material, even pure iron, to remain magnetized. The thermal collisions of the atoms are too vigorous to allow the spins to remain oriented. That leaves a large-scale electric current in the interior as the only possible cause of the magnetic field. So a lot of people don't know this. If you have a permanent magnet, like a horseshoe magnet, if you expose it to high heat, it's going to randomize the orientation of the molecules. And the way the magnetic field is generated is they're all kind of aligned in a certain way. And so you have this kind of circulation current, I think. And when you have a circulation current, it creates a magnetic field. When you heat it up, you can destroy all these magnetic domains and you lose it. So that's what he's referring to. Also, it's not well known. you can take a hammer and just kind of hammer it out and start messing up the domains. That vibration will start to mess up the domains. You'll demagnetize a permanent magnet. So let's go on. So that's a nice Sir Joseph Larmor. So let's see if I could get this. Okay, so let me do a hide screen here. Electric current in the Earth's core is like a spinning flywheel. So, okay, an alternative to a permanent magnet is if you have a spinning flywheel that will also generate, I believe, a magnetic field or an electric current. So, okay. And then we have here, he's going to refer to Sir Joseph Larmor, 1857 to 1942. Okay. Left to itself, such a current would die away in less than a few dozen millennia. Okay, so the current theory, what Humphreys is saying, left to itself, such a current would die away in less than a few dozen millennia because the electrical resistance of any conceivable material in the interior would wear down the current. Just as friction slows down a freely spinning flywheel, figure 1. Okay, I got that wrong. It's not a flywheel. He's talking about the current. So let's go back here. A large-scale electric current in the interior as the only possible cause of the magnetic field. So we have all these, I guess, electrons creating an electric current. We're just kind of spun up, and if it encounters resistance, it's going to die away. So we'll just move on with this. All right. So, and the electrical engineers out there know what resistance will do. It's going to kill the current eventually. For creationists who are convinced by both the Bible and much scientific evidence that the Earth is only about 6,000 years old, such decay is no problem. In fact, it explains very nicely the steady weakening of the Earth's magnetic field for the past few centuries. Creationists theorize that God started the electric current when he created the Earth, doing likewise for the heavenly bodies. But uniformitarians who believe the Earth is billions of years old assume that some natural process started the electric current and maintained it for eons. Nearly a century ago, Sir Joseph Larmor, a well-known Irish-British physicist, was the first to suggest such a scheme. It was an article trying to answer the question, how could a rotating body such as the sun become a magnet? He rejected several ingenious but implausible possibilities. Then he outlined a possible solution. The first being a long series of dynamo, the British word for electric generator, theories. And he writes, in the case of the sun, internal motion of the conducting hot gas in the magnetic field induces an electric field acting on the moving matter. And if any conducting path around the solar axis happens to be open, an electric current will flow around it, which may in turn increase the inducing magnetic field. In this way, it is possible for the internal cyclic motion to act after the manner of the cycle of a self-exciting dynamo and maintain a permanent magnetic field from the insignificant beginnings at the expense of some energy of the internal circulation. Okay, that is really thick, and it'll take some serious electromagnetic theory to describe what he's claiming and why it's false. Okay, that paragraph that we just read is, even I cannot uncoil it in just these brief few minutes. This would take, this is going to be taking hours just to think about what this is describing. All right, just so if the viewers see this and their eyes roll, it's like, well, you're not the only one. This is not easy stuff. Right. So self-exciting alludes to the type of generator that makes its own magnetic field without any need for an externally applied current or field. Later the same year, Larmor, okay, let me just think about loose. Okay, let me just back up a little bit. Let me just back up a little bit. How do we generate? So you can either have a permanent magnet or an electromagnet. So the permanent magnet is just like your door refrigerator magnets. They're just permanent. An electromagnet magnet is like in your automatic lock. It creates magnetic fields. So like if you've ever seen, also here's a better example. Let's say if you've ever seen this at a junkyard, you have a crane and it can go pick up a car by using a magnet, and then it brings it to where it wants to dump it, and then it releases it. So what happens is the electricity goes, it's actually kind of simple. You can actually build this. If you have something that's iron shaped like this, you wind copper wire around the iron core, and then you send electricity through the wire, you create an electromagnet. And that's kind of how that crane can pick stuff up like a car. It sends electricity into the electromagnet. The electromagnet then creates a strong magnetic field that strong enough it can even lift the car. And then when the crane moves and wants to drop it, it just turns off the electricity, and then the car drops. So the problem is how can we generate electric currents spontaneously? I mean, if you have a wire, like if you have a light bulb, what do you have to do? You have to power it somehow. You just don't have spontaneous current going through it. And that's kind of the problem. He's trying to figure out how you can generate spontaneous electric currents. And you know, this is almost like a perpetual motion machine, guys, and I'm sorry to say that. So now we can get, like, if you had a windmill, you can take random air currents and convert it to electricity. That's certainly the case. So it's not completely impossible that you can take, you know, kind of random energy and then direct it, but you need a machine to do that. And we know machines don't self-assemble. But he's trying to postulate how you could have a self-assembling machine, essentially. So we'll see. Okay, let me just keep going here. Later the same year, Larmor specifically included the Earth in his hypothesis. Ever since then, hundreds of geoscientists have worked hard on developing a hypothesis into a theory that works. They have done theoretical analysis, numerical simulations with large computers, and laboratory experiments. Here I outline the history of those efforts, showing that, astonishingly, they have still fallen short of proving that a dynamo is working or even could work in the case nearest us, the Earth's core. So let me just take a break here and recognize Mark O'Connell. He has a question. And thank you, Mark. It's always great seeing you. With the sun, we have effects of gravity to feed the process. Okay. So let's go back to this. The importance of that apparent failure is that it leaves only one alternative explanation for the Earth's magnetic field: free decay of electric current in the core. Free decay is only feasible over a period of thousands of years, not millions or billions. So the absence of a dynamo in the core supports the idea that the Earth is as young as a straightforward reading of Scripture says it is. So okay, this is great. There are anti-dynamo theorems. After Larmor introduced the idea of a self-excited dynamo in the Earth, there was little comment in the scientific literature for over a decade. But in 1933, a young English astronomer with good training in mathematics, Thomas George Cowling, threw a big monkey wrench into the machinery of dynamos. With straightforward mathematics applied first to the magnetic fields of sunspots, Cowling showed that simple forms of the dynamo idea couldn't work. Considering steady magnetic fields, he wrote, 1933, a field which resembles an axially symmetric field in certain respects cannot, in general, be maintained by the currents it itself sets up. We are led to conclude the magnetic field of the sunspot is not self-maintained. For the same reason, the general magnetic fields of the sun and earth cannot be self-maintained, as was suggested by Larmor. Okay, so let's look at this, at these figures, and I have some comments. And I think I'm a little tired. I think we're going to just cut this in small pieces because this will take a lot to digest. So we'll see if we can go 45 minutes and then quit. So that's Thomas George Cowling, 1906 to 1990, Royal Astronomical Society. So he's very senior. And 1990, he's in my lifetime. And then we have a self-excited electric generator driving steam engine. Okay. I'm assuming he'll refer to this. Russell Humphreys, that is. Okay. For planets, axially symmetric field means that as you rotate azimuthally, that is east to west, around the magnetic axis, a line through the north and south magnetic poles, keeping your altitude and latitude constant, the field will remain constant. The magnetic field outside the Earth deviates from axially symmetric by less than 10% at any point. Okay, we may have to revisit this. Cowling's results spurred a great deal of theoretical work to check it, generalize it, and look for loopholes. It was not only found valid, but over several decades, theorists found a series of anti-dynamo theorems that made Cowling's result more rigorous and more general. In 1956, they removed the restriction that the fluid velocity and the magnetic field direction must be in meridian planes. Ugh. The following year, one of those theorists removed the restriction that field must be steady. He showed the fluid motion cannot prevent the decay of the external dipole moment and cannot lengthen the decay of the dipole moment over a factor of about 4 over its decay time in the absence of fluid motions. Oh my goodness. What do we do here? They have just thrown a ton of technical terms at us. And I'm sorry to be reading in monotone, in a monotone voice, but you can't get through. This is so thick, I have to read it slowly so I can digest it as I'm reading. Do you hear all the terms we just threw out? I'm going to have to try to guess at what it means. Anyone in the comment section of the video can weigh in, and maybe this also motivates me to chop this in pieces so people can comment in the video if they object, or especially if they need to correct something, a misstatement I made in my understanding. So what does axially symmetric? Let me get a globe. Wow, if you think I'm putting you to sleep, I'm putting myself to sleep reading through all this. Okay, so axially symmetric. So guys, now you know how we can read through this. This is not easy reading. Okay, it says for planets, axially, let me go back here. For planets, axially symmetric means that as you rotate azimuthally around the magnetic axis, as you rotate azimuthally around the magnetic axis, keeping your altitude and latitude constant, the field will remain constant. Okay. Um, let me try to illustrate this, what it means. So we have, you can see the Earth rotating on its axis here, like that. So the axial, the axis of rotation, you see, you have an axis of rotation. The magnetic north, okay, so you have the axis, the axial north and the axial south. That's correct. What ends up what we actually know is the magnetic field. Magnetic north is not actually, magnetic north does not align with the axial north. We're almost axially symmetric, but not. This is very interesting because just as I was pondering this, one would think, oh, well, if you have a rotating body, why can't that generate a magnetic field if you have charged particles? Well, the problem is you have a magnetic field that is not aligned with the rotation, the axis of rotation. Your magnetic north is not the same as the axial north, what we sometimes call true north. And this leads me, I think I just want to go on a rabbit trail because I think this is important enough. Speaking of which, Bugs Bunny. That was fortuitous. Bugs Bunny. Why did I use the word gruesome? There is a Bugs Bunny episode where Bugs Bunny says gruesome. So that's where I got that. So let's look at magnetic north. Make sure I got this right. Magnetic north. The North Magnetic Pole. The North Magnetic Pole is a point on the surface of the Earth's northern hemisphere at which the planet's magnetic field points vertically downward. In other words, if a magnetic compass needle is allowed to rotate in 3 dimensions, it will point straight down. There's only one location near but distinct from the geographic North Pole. Okay, the geographic North Pole. The geomagnetic North Pole is the northern antipodal pole of the ideal dipole model of the Earth's magnetic field, which is most closely fitting model of the Earth's actual magnetic field. The North Magnetic Pole moves over time according to magnetic changes and flux lobe elongation, blah, blah, blah. Okay. In 2001, it was determined by the Geological Survey of Canada to lie west of Ellesmere Island in northern Canada at 81 degrees 18 minutes or 18 hours. Someone help me here with lat long, and this is pathetic. I should know this as a pilot, how to read lat longs. I've forgotten, and I was in aviation navigation. Oh my goodness, this has been too long. It was situated at 83 degrees 6 minutes north, or 6 hours. Help, someone. Someone help me how to read that. Anyway, let's look at this link. Degrees, minutes, and moments. Thank you. So we have the geographic North Pole. We also have a North geomagnetic pole and then a North magnetic pole. Oh my goodness, now I'm confused. Oh, now I'm confused. North geomagnetic pole. Let's see, where's Canada? There's the Arctic Ocean. There's Greenland. So this is Canada here. And then we have this other thing here. North geomagnetic pole. And then there's another pole that I don't understand, which is you have the North geomagnetic pole, and then you have the North magnetic pole. Ugh. I didn't even know that there was such a thing as that. Okay, so I'll just go North magnetic pole. I'm a little bit confused, guys. I'm sorry about that. But anyway, you could see, well, I don't want to get too far off track here, but suffice to say there is a magnetic pole, and then there's the geographic pole, what I earlier referred to as the axial North Pole. So going back to this, we have the North Pole, the geographic North Pole, or what I earlier called, probably erroneously, the axial North Pole. And then, let's see, this right, way up somewhere here is the magnetic North Pole. Okay. Oh, boy, this is why this stuff is hard to just slug through. Okay, so for planets, axially symmetric field means that as you rotate azimuthally, east to west around the magnetic axis, a line through the north and south magnetic poles, keeping your altitude and latitude constant, the field will remain constant. The magnetic field outside the Earth deviates from axial symmetry. So it deviates from axial symmetry by less than 10%. Okay, so the field strength will not remain constant. The field will not remain constant. So if you, okay, so it says keeping your altitude and latitude constant. So a pilot friend where I work, he said the way to remember latitudes is ladder. So, okay, so you could see the latitude lines here. So the equator is the easiest latitude line right there. That equator. But then you have other latitude lines, and I'm just going to keep the latitude like that, constant. As I travel here, I'm going to just keep the same latitude. And I could jump to another latitude line. So what they're saying, it'll be really pronounced here when you take, like, say, latitude, what was, let me see, I'll just pick the latitude. 78 degrees, 78 latitude 78, okay, latitude 78 degrees. Let me look for 78 degrees. Does it have it here? This is 60, 45, 60, or 78. Okay, 78 degrees. I got it right here. 78 degrees latitude is about right there, right at the edge of that, right there. So if I rotate there and let's say you're just flying at really low altitude you're flying an airplane at low altitude. As you go around there, the magnetic field is going to change in strength because it is not axially symmetric. I know that's just like belaboring the point, but I don't feel comfortable if I don't even understand little paragraphs like that because it might have to be referred to later on. And so I'm just trying to acquaint even myself with the terms. Boy, that was painful. So going back to the paper, that was agony. So that explains that paragraph. For planets, axially symmetric field means that as you rotate azimuthally, east to west around the magnetic axis, keeping your altitude and latitude constant, the field will remain constant. The magnetic field outside the Earth deviates from axial symmetry by less than 10% at any point. Cowling's results spurred a great deal of theoretical work to check it, generalize it, and look for loopholes. It was not only found valid, but over several decades, theorists found a series of anti-dynamo theorems that made Cowling's result more rigorous and more general. Okay, now I'm going to just back up a little bit. So there's Cowling. God bless him. It was with sunspots. Okay, I'm going back here, but in 1933, a young English astronomer with a good training in mathematics, oh goodness, you need a good training for electromagnetic theory, Thomas George Cowling threw a big monkey wrench into the machinery of dynamos. With straightforward mathematics applied first to magnetic fields of sunspots, Cowling showed that simple forms of dynamo idea couldn't work. So this is what I wanted to look in. Are there magnetic fields in sunspots? And there we go, Bugs Bunny, Mr. GRUESOME himself. Sunspot magnetic fields. Sunspots are caused by disturbances in the sun's magnetic field welling up to the photosphere, the sun's visible surface. The powerful magnetic fields in the vicinity of the sunspots produce active regions on the sun, which in turn frequently spawn disturbances such as solar flares and coronal mass ejections. That's news to me. I didn't know that. Disturbances in the sun's magnetic field welling up to the photosphere. The powerful magnetic fields in the vicinity of sunspots produce active regions on the sun, which in turn frequently spawn disturbances such as solar flares and coronal mass ejections. So the sun's magnetic field is very strong, and there are disturbances. So that's why Cowling's theorems are very important to understanding solar spots, sunspots, and then which would result in solar flares. This is amazing. This is great electromagnetism, great astrophysics, great physics, great electromagnetic physics, great astrophysics, solar physics. Okay. In 1956, they removed the restriction that the fluid velocity and magnetic field direction must be in meridian planes. What is a meridian plane? I should know this. Being in aviation navigation, I've forgotten so much. See, what is a meridian plane? Meridian plane, it is defined as the plane PA passing through any point A on the surface of the North and South poles. Equator, equatorial plane is the plane passing through the Earth's center of mass and perpendicular to the rotation of axis. An equator is the intersection of the surface with the equatorial plane. So let me just look at this here. That's not very helpful. Let's click here. Yeah, electromagnetic theory has just a lot of this geometry, trying to understand the shapes, trying to visualize it. It's not trivial. So we have a meridian plane. So we can, it's basically like how we can slice it through. And I don't know if it has to go through the center of the sphere. Let's read this. Meridian plane, it is defined as a plane PA passing through any point A on the surface of the North and South poles. Any point A as the plane PA passing through any point A on the surface in the North and South poles. So if we take an arbitrary point, okay, I think I know now. Okay, this is tough geometry. So we have a plane. Let me go through this. Delete that. So if we take a point and we're going to create a plane that will include the North and South pole plus that point. So going back to this, if I try to slice, I have to go through the North and South, and that's easy. And any point. Okay, so it'll be basically slices like that through North and South. Okay, okay. All the terminology is just brutal. Okay, guys, try to wrap it up now because we're almost at an hour. Usually college lectures are 50 minutes, and technically then I'm over limit. So why don't we just call it a day or call it a show for now? And let's see how far along we are in this GRUESOME lecture. Okay, let me just show my window here. You could see we're this far along in the talk. So that looks like this will be at least a 7-part series. All right, guys. Thank you, everyone who joined us. This has been very enlightening. And so let me just bring out the closing credits. And thank you again. God bless you all.